All right, got the stream up on YouTube. I have not figured out how to get it on Twitch yet. I will do that another time. But today we're going to stream. Today I'm working on my debugger, and we'll see how far along I can get on that. Let's get to it. I got a new keyboard, and so I'm learning, change the layout a bit, so things seem a little crazy. It's because I'm trying out these homegrown mods, seeing if those are worth using. So last time I was working on this, I was working on encoding this variable length data, or decoding it, so that we could start decoding our abbreviation table. Make this a little bigger here. Okay. Let's see it. Let's zoom in a bit. Oh. See what I mean? Anyways, let's search for, actually I know where it is. Oh, yeah, variable length data. Oh, I know, I've got it, yeah, got that done. I need to go back to this part here. Got the unit header parsed. Looking for is the abbreviation file. There we are, abbreviations table. Each declaration begins with an unsigned integer. As described above, the abbreviation code 0 is reserved for null. We have all the tags. I've already got those. Following a tag encoding is a 1-byte value that determines whether the debugging information entry uses this abbreviation has a child entries or not. Okay. I have that here, my slice idea. Kind of the format I'm going for here is abbreviation. It's going to contain a list of, this is abbreviation table. I should probably rename the file. Anyways, the abbreviation table has a format, has a list of formats, has some list of extra data, which we can get into in a bit about what that's about. And then it has the abbreviation codes. And so then with the abbreviation codes, let me see. Whoops. Oh yeah, because each abbreviation has its own code. We then need to be able to map them in. That's right. So now I was working on building this. Sorry, it's been a week or two since I've been able to touch this, so get the mouse out of the way. When I was working on the parser, the idea is that we've been given the bytes of the abbreviation file or the abbreviation table. First byte is always going to be the ID, but that's a unsigned, the code. Let's write out the algorithm here a bit. So let's do this. Okay. First, it's kind of recursive in a way because what happens is you get an abbreviation. It starts with the code. So really what we need to parse is one of these formats first, right? Or one of these slices is what we're really doing. Every time we're making a slice. Kind of doing it at the same time. So what we really need to do is get the code while there are abbreviations to be done, right? So while there are abbreviation to be done, first get the code for the abbreviation. Then we read if it has children. Then we log the start index and begin a counter. Okay. Then while there are tags to read, right? Tags. While there are tags, while there are, what are they called? Format items to read. We 1, 2, 3, 4, 5. Parse a new format using and store it. Increment the counter. Okay, so let's do this. While true, this needs to be updated. Let's see. Fix me. To be updated so that it is correct. Updated so that it actually ends when there are no more um, abbreviations. Okay. So while true, see first you get the code. So code const code equals ulib, right? Ulib the bytes. Yeah, code and delta, see const var delta usize. All right. I think I'm missing something here. I think I also have to read the tag. It says abbreviation table for simple compilation unit consists of a series of abbreviation declarations. Each declaration specifies a tag and attributes for a particular form of debugging information entry. So that's what we're really looking at. It's the tag, and then we're going to do the. Okay, begins with a unsigned LEB 128. So ulib 128 number representing the abbreviation code itself. It is this code that appears with the entries. So this is the code that identifies it. Okay, so this is the first thing. Then after that, then there's another to get the tag. Okay. So then there's the const, tag, and then let's see this. Delta, let's see, offset. Bar offset equals our offset equals, oh, actually we need to put a usize 0. Why not? If I not set a key code for 0 on my computer, my key code. Okay, let's look at this. 'qk configurator. Test keyboard. Let's see. I want to see if, oh, that's a Z, backspace 0. It's got shift. Zero not. I never update. Okay. There we go. I see my mistake now. Okay. Let's redo this then. Okay. Okay. Go to keyboards, CRBKB, CRKBD, key maps, vim dot keymap.c. Oops, F. Let's see this. Uh, 1.4. It's the keypad, and there it is. F. Okay. That's what we need. All right, and W, Q. Q and K. Q and K flash. It's okay, fine. What's the word I'm looking for? Nemo. There's F. Okay, close. Now let's test it out. How to get zeros. Okay. So now if I say, okay. Okay. Get toss out of the way. Let's see. All right, there we are. So the plus equals offset. Set. There we go. Plus equals delta. Control Y. There we go. Enter. Backspace. There you go. Shift A. Const tag var and then delta equals ulib bytes offset. Okay. We gotta figure out what's wrong here. It doesn't like found expected blomp found this struct. Oh. There we go. Doesn't like unused constants. We'll use those constants here. Let's see. Let's just apply the fixals for right now. Okay. Oh. There we go. That gets us the tag. Now, it's interesting about this, and there's probably some kind of minor optimization. I'm not really deal with it right now. We'll just truncate. All the tags have to be, even though it's encoded in ulib 128, which can give you a 64-bit integer. In fact, maybe I make that change here. Let's do that. Let's do that right here. In our private ulib, I'd like to be able to say the type. So let's do type. And instead of returning that, it returns type T. Okay. And then what we'll do is we could do some checks here, but really T, you could do like some assertions, but should be good enough to do that. UT Okay. What we need to do is add like a test that actually parses some data. Let's add some tests for our ulib 128 so we just make sure this works correctly. I think, and I don't think, I know there's wrong problems with it. So let's do test. ulib, I like doing it like this for what I can. DIXX, there we go. What we'll do is give it some ulib. What's a good test example? They have some in here. It's just so I don't have to think about it because thinking is hard. See, yeah, here we go. So let's test some of these. Oops. Let's see, see const input equals okay. 0x2. And then what we expect is the output is see test see. And they're at testing. Come on, expect. Ugh. Expect equal. And expected type is going to be, or expected value here is just going to be 2. The actual value is going to be ulib 128. And here I want it to be a was it 1 U32 and the input probably need to be ref input or take an address to the input. Pointer to the input. Okay. Probably just to make sure we do. Oops. As to as I'm starting to get a hang of this keyboard. It feels like a baby elephant learning to walk, but We're getting there. So did this test run though? I don't think it did. Oh gosh. Let's see, const. No, it's test. And the test we want to do is standard.testing.ref all decals at this. Okay. And now we need to go make sure abbreviation is refed in some other files. Let's see. That's actually being tested. Main, let's go to dwarf. Ah, there we go. FA. Okay, there we go. Now we're getting some errors. Let's go back to abbreviation. For G. Oh, 74, 70. Oh my goodness, 74 G. There you go. Right there. Expected type U8 found const pointer to const pointer to const pointer to U8. Found expected U8. Oh. F. Okay. Abbreviations 50. Expected 2 arguments, found 1. Perfect. This gonna be a U64. Because we don't know how long that one, but we know that this one has to be a U32. We know the tag has to be U32. Okay. Just has to be. I should probably make an assertion here. Like standard. Hey, Vinpol. Thanks for watching. So you can do like standard.debug dot assert. Oops. There we go, assert. And then what we want to assert is that I, we're returning the I plus 1. Right, is not greater than let's see, like log 2 I plus 1 is less than or equal to what is it? Standard dot math dot log to int. See this with this. Log to int. Returns an unsigned int type that can hold the number of bits in T minus one suitable for zero-based bit indices of T. That's not what I want. I want to make sure that the bit size of oh no way. This again, I've had that happen with me before. I've already made a bug report to Neovo this. That's funny. I thought they had fixed this. All right. It's not something super big. Big problem is that I am still learning my keyboard. There you go. Yeah, I had seen that on my work computer, but I run Whizzle on my work computer. I had never seen that on this one. So where were we? We were making sure that, well, let's get this test to pass, and then we could talk about whether we want to assert things here. Yeah, U32. Okay, so 22. We need to go back here and fix these. This is a U64. Yeah, I should say it more often. U32. You know, it's the only bug I've ever had I've encountered with NeoVim crashes, but it's the same one, and it's pretty tricky. But I did report a pretty solid way to recreate it. There was a workaround, but it required me building my own version of NeoVim with a slight change, and where I'd never seen it on my personal computer, I just figured I wasn't going to go through that hassle. Not that building NeoVim is a big hassle; it's actually pretty easy to do. But I just didn't want to do it. So maybe I'll have to get around to doing it for this one, because whatever fix they have didn't fix it. Actually, I don't know if they actually did fix it. Okay, let's look at this. Let's take a look at this. CT github.com. That's no, I don't want. This is where do I find like notifications? Let's just go to NeoVim. GitHub NeoVim issues. Mark tree. Oh gosh. It's one that I've. Is there a way to like check if I participated in it? Commenter. Me. There it is. So it is still open. Okay. I thought they had fixed it, but yeah. Okay. Well, I stand corrected. Yeah, I never set up autosave for NeoVim. I'm usually really good at just always saving, but like I said, I've got a new keyboard that I've been playing around with, and I changed the layout a bit, and it's messing me up. So then I kind of become wary about saving, not because, but just because it's a little painful to see. Okay, I just need to practice the save. See, we're gonna save a bunch. It's not so bad. Okay. Where were we? Okay, now it's saying U6. That's what I thought. 64. Shift, expected U6, found U size. Yes, so we need to do all the casting here. So, in fact, why don't I just... Oh, wait. So ULEBS 128 can only have up to 10 bytes for a 64-bit number, if I remember right. Because, yeah, it has to have 10 bytes to do 64. So a U3248 isn't enough. It needs to be at least a U4. U4. Which is going to be a problem here because the shift value is a U6. Because, yeah, so expecting it to be U3. Okay, so this is where it gets a little hairy with the stuff. So maybe we need to do some things like var, not var, const s equals type info t dot c. It's going to be an int dot bits. So we know, so 64 bits. When you're shifting a bit, the shift size cannot be greater than what is it? Log 2, log, yeah, standard.math.log 2. Oops. No, standard.math.log 2. There we go. I believe that's right. Because then if we put a U64, log 2 of 64 is 6? Yes. 2, 4, 8, 16, 32, 64. Yes. Log base 2, 60s. Yeah. 6. So that'd be right for that one. And then again, when you're shifting a number, like I could do U size here. Let's go back to the U size. XP there. XP, there you go. There we go. So we're going to add the shift and saying, hey, this should be a U6. So if I change this to be a U6, now it's going to get mad because the shift operator needs to be a 3. Because U32 is 3. That's right. 2, 4, no, it's 5. Yeah, log base 2 of U32 is 5. So, um, uh, was it type standard dot built-in dot type yeah, type is the right one. And what we want to do is int bits equals that. That's sign, and then that's signed to this side. Yeah, that's signed to this, that's signed. This equals dot unsigned. Now what's it complaining about? Ooh, lots of stuff here. Okay. Says unable to resolve comp time value. Oops. Incompatible types U32 and struct U32. Okay. Const type of expected actual. Oh, yeah. That's a big problem there. That's a good point. So we need to go back to the test here. And it's this dot, yeah. Okay, now saying error union is ignored. Okay, still getting an error here. Let's take a look at what the error is. Unable to resolve comp time value. Yes, types are not available at runtime. So I think I'd have to mark this expressly as a comp time int. Oh, I missed some this. Yeah, I was just about to put in some music for work on some assignments for Intro to Java when I saw you ready. Oh, well, I'll try to not distract you from your assignments for your Intro to Java. I will have to say that Zig is, I think, better, but don't want to distract you from your schoolwork. Java is not my favorite language to program in. Let's see, let's do comp time. S. Great. That's funny. There we go. Expected. Oh, yeah. I keep doing that. I will remember not to do it sometime. Expected type found built in that type. Oh, I need to reify the type. At. I get that type, yeah. Type. CPP better. I only took it to get my, yeah, an electronics tech job market. Bachelor's. An EET. I don't know what that stands for. Electrical engineer tech. I don't know. The live streams should just be saved. So yeah, they're automatic. Since this is YouTube, I don't like do anything else. But yeah. But thank you for subscribing. Yeah, I've been doing some videos on just intro to Zig and some low level stuff. So let me know if you like those videos and if there's anything else you want to see. And then yeah, when I live stream, I mostly work on my debugger, which is slow going. I don't have a lot of time between work and life, but it's fun stuff to do. Electrical engineering technology, cool. Very cool. I did mechanical engineering for a semester and I was not smart enough. The physics was too much for me. And I know electrical engineering is much more difficult. What electrical engineers do is magic. So thank you, Fimpol. Okay, so expected type U3 found U6. I know I've dealt with this before with all the shifting. Unsigned 3-bit int cannot represent all possible unsigned 6-bit values. That's easy. That's fine, because we can upcast if we need to. I don't think that's the right answer. I'm just having some deja vu here. Holy cow. Really bad deja vu. Oh, this is shifting is a pain sometimes. Zig, Lang. What is it again? It always trips me up. Operators. So shifting, here he is. Moves all bits to the left, inserting new zeros at the least significant bit. B must be comp time known or have a type with log2 number of bits as A. Okay. I can deal with that. Because B is not the shift here, the shift here is Oh, let's see. I did computer science. I started university in 2016, but I ended up getting hooked on pot and booze. I'm only now take my education seriously. I found a passion for math recently. That's good. They don't teach trig well in university. 3 blue, 1 brown. Is it? What would you say Zig is useful for? I'm interested in learning functional programming, which I know is more of Rust and Lisp. Yeah, Zig does not do like functional programming per se. It's not a functional programming language. It's a very imperative language. So if you're interested in functional programming, Zig's not gonna scratch that itch for you. Zig's much more focused on, well, if you look at the website, if I could remember the key switch, there it is, right? General purpose programming language and tool chain for maintaining robust, optimal, and reusable software. So general programming, it's very low level. And so sometimes people say systems level language because it's allows you to do things. It's not necessarily a C replacement. I mean, yeah, it's a replacement for C, but it replaces C by interoperating really well with it. So you don't have to rewrite all your C code if you have C or even C++. But yeah, if you're into functional programming, Lisp is one I've never really got into, but sounds interesting. Yeah, there's if you're interested in Arduino and Zig, there is a group there. Zig embedded Zig embedded team? Zig embedded the Zig embedded group. And so they've got some interesting information about how to set up things for doing Zig embedded. I've not done embedded with Zig. I've done some embedded stuff, like I made my keyboard, which I'm having so much trouble with today. And I've used C for that, and I played around with Arduinos a little bit. But I would like to get into doing it with Zig. It's just not what I'm into right now. But yeah, I am. If you're interested in that, I check out the Zig embedded group. They've got a libraries set up for working with Arduinos and Zig. Well, thank you. I try to not I could go on a rant about AI, and if you spend any time on Zigit, which is a website that I run for a forum for Zig, yeah, you'll see. Not that anyways. Yeah, we'll just leave it at that. So where were we? Oh yeah, so the signed bytes. Okay, so we have our shift here. This value, which is a U8, can only be shifted by a value that has the same log 2 number of bits. 2, 4, 6, 8, so 3. Oh yeah. I will link to it real quick. Let me do that. Zig embedded group. Copy. Let's see. Fork send message. Or fork send Zig embedded group. Control Shift B. Okay. Okay. So yeah, so this shift has to be at least a U3 because it has to be a byte. So yeah, the shift value has to be U3 always. Because we're always going to be shifting a byte here. The I has to be a value. I doesn't have to be, because I know that, well, so yeah, now here we go back again. Type expected U3 found to U6, which makes sense because when we're multiplying here, we're going through now U3, 2, 4, 8. It's not enough. Wait, no. Awesome. I think I'm doing this wrong. See ya. Thanks for stopping by. Shift U3. Because the shift is always plus, so oh. Yes, okay, no, never mind. So this is okay, I made a mistake here. Not a bad one, but I misunderstood what I was doing. So we're not always shifting a byte. If we were, that would be fine. What we're doing is shifting, we're always gonna take this byte and then we need to shift it into the result. The result is of type T. And so we need to this byte to be cast as a type B. As oh, sorry. I'm working on a debugger. You can always ask. Don't worry, because I think you're the only one watching. So I was not explaining a lot. I'm working on a debugger. And in the debugging spec for Linux, well, it's not just for Linux, but it's the dwarf format. There is, let's go variable length data. There's a certain way they encode integers. You might have heard of them if you've done like Go. The way they encode integers in a lot of spaces is in Little Endian base 128 format, which just means you take first 7 bits of a byte and those encode the number, and then the last bit encodes a continuation. So if it just says, hey, does this, are there more bytes to be continued? The reason for that is then you can encode small numbers with just a few bytes, and then large numbers you take more bytes. And so for the price, for the cost of 1 bit per byte, you are able to save bytes if most of your numbers are small. And so like if you're doing a sequential counting, and most your sequences are less than 127 values or 128 values, then you actually get to save a lot of space. And so I need to decode those. Now Zig has a built-in uleb 128 parser, but I need it to return the number of bytes that were parsed. And I could do that by calculating it out, but it's just easier to count it as I parse it. And eventually, I was reading a paper here the other day about using SIMD. So I'm hoping I can use some SIMD to really speed this up, because ulib parsing comes up a lot in the dwarf format. Being able to parse out this, and especially here at the abbreviation table, which is just a table that shows when you compile your program. When you compile your program and you get the dwarf debug information, what it does is it identifies different places in your program of different features or different kinds of things. So let's kind of give an example. Where is it? Yeah, DW here. You can see all the tags. So you get like array types, class types, entry points, labels, importer declarations, members, inheritance, which we're not going to deal with in Zig, but we should support in case we want to debug other things with our debugger. Subprograms, that's going to be functions, right? So all the different types of things in your program are there, and the abbreviation file shows you. Abbreviation table takes all these tags and says, hey, for tag, here's a code 123. 123 is an array type, and then here's the different kind of attributes that you can get off of that. So that's what we're working on. I'm working on decoding right now. So always feel free to ask questions, because I know I'm not the best at explaining what I'm working on. But yeah. So right now, with the way that the algorithm for parsing ulib 128 is, you go through each byte, and I start out with byte with the 1. That's just to make sure that we go through the first iteration of the loop. And then I take a counter. That counter is just to tell me how many bytes I've parsed into the number, and the shift value, and we start at 0. So while the byte and this hex value 80, which just means while the most significant bit isn't set, advance will add 1 to the I. Oops. So that starts at 0. We add 7 times I to the shift, because every time we go, we need to shift 7 bytes over. We get the next byte, and then we take our result, which started at 0, and we bitwise OR it with the byte masking out the highest order bit and shifting it some multiple of 7 bytes over. So that way we're slowly building up these 7 bytes into a single bit string to create numbers. So what you need this is to be as a T as type T. That should be good. Yes, I think that was really good. Okay, expected const. Okay, so now expected const U8 found U8. I always forget that. Okay, that works. It compiles and our tests work. Let's add another test. Did I delete my... okay, let's see. Zathura. Let's open the Zathura up here and open. And yeah, we were at the variable length data. I had some examples here to test out. I wanted to test it out. So let's do 127. X, and it says the first byte should be 127. So that's FF. No, 7F. And the value should be 127. I did not get the right value. Roots testing has no member expect equals struct. It doesn't because I accidentally deleted the E. Okay, that works. Let's do some more. I want to test out U8. I know this is a byte, which I know this can be encoded in just 1 byte. Will this still work? It does. That's awesome. Do they have any more examples of ones that take up more bytes? Yeah, they do. Let's do 12.857. F that, and this is going to be, let's do what, U16, because I know this takes 2 bytes. And we're going to do 12.857. And 16. Oh, I did that wrong there. Well, let's see if this works. And the byte string should be 57. 57 plus hex 80. That's kind of annoying that they they do this in decimal different ways, but let's just. Oh, I know it. I've got it. 57 is hex 39. So 0x39 plus 0x80 is going to be 3 plus 8 is 11. So that's 0x b b9 not 0x flash x, and then it should be followed by 100. It's 100 in hex. $64. That's kind of ironic. I should remember that. 64. And that works. Okay. I am sufficiently convinced that my with get ulib parsing working. Oh crap. Sweet. I did remember the password. Yeah, let's not forget to save, and now I've got it committed too. Okay. So we've got that working. Yeah. Okay, this is bothering me. Okay. Didn't like how long it was spanning on that line. Okay, so now that we've got that parse there, we can go back to parsing the actual abbreviation table. So this the whole little runaround was because when we're parsing the abbreviation table, curses. Oh, I don't know how to go back to undetached node. Okay, there we go. Zathura, let's open that up again. Okay, and Windows. Oh, that is not what I wanted at all. Interesting. Oh, how do I swap? This is like Windows Shift O. No, view. Everything's all over the place. Okay, that works. Ish. Okay. Oh man. And now we got to get these all in. So let's put that. Okay, there we go. Got to reset everything. There we go. I don't want LibreOffice open. Stinking new keyboard. Messing me up. Okay. Okay, there we go. Now. Okay, Control D. V, Control Enter. There we go. Okay. Ugh. Zathura. Now, there we go. Everything's back to where it was. CD /VDB. Okay, there we are. Nope. I just need to go slower here. Okay. So everything I was trying to say is in this debugging format, when you're parsing a abbreviations table, it starts with a code for the abbreviation. Every abbreviation has a code. And then every following that, there's a tag. And the code can be, you know, some arbitrary number, but the tag is always going to be a 30, at least a 16-bit number. Actually, it can't be any more than 16 bits. I misread that. So actually we can U16. But I believe the tag is defined. Oops. Let's take a look at our tags. EW. I have them as the U32. So to make things simpler on us, we'll keep this a U32. Okay. So now that we got the tag here, we now need to parse 1 byte. There we go. So const has child. Equals. It's gonna be the next byte. Oh, I need to do that again. And has child is going to be just the next byte. So it's bytes offset. And actually make it a bool. Let's do bytes offset equals 1. Yeah, 0. No, equals 1. 1 is true, 0 is false. So we want it to equal 1. Yeah. It doesn't like that these constants are unused, so we'll just apply the fix all for right now. Just to make sure everything compiles. Awesome. So after I've parsed it, then I can take the abbreviations table and I can go into, here, I'll show you. I can go into the debug information section and start parsing that out and building out the debug entries, the debug information entries, because you need to know the abbreviations to be able to parse the debug information entries. It's a bit convoluted, but I guess it kind of makes sense. Instead of saving, to be able to be, what's the word I'm thinking of? Fluid in the format of each debug information entry and what kind of features it has. There has to be something that says, here's how you parse this debug information entry. But if there was, in order to save space in the actual debugging information, rather than repeating that format every time you use it, there's just one spot for the format. It says, hey, and so when you're reading the debug information section of your executable, you then say the first value is going to be, it's the code that we're parsing right here. This code is the first value in the debug information entry. And so then it tells you how to go, you go look up that code in the abbreviations table. And you say, oh, okay, this is this type of tag and it has these attributes. So this is how I parse out the next set of bytes to get that information. And the thing I was going to show here is here, if I do like a object dump dash W, and let's do the zig out bin slash test bin. You'll see all this information that gets spit out here. Let's pipe that to less. And this is particularly the debug information from my my test debug file. And if I go to like a brev, you can see here's the debug abbreviation section. This is what I'm working on parsing right now. So you'll see that you'll get the number tag 0, and then you get a 44, which is the number, that code. So everywhere in the debug information section, which you can look at here later, where it says 44, we'd say, okay, this is a debug structure type. This one has no children. And then the attributes are as a declaration file, and the form of that decal file is a udata that has another attribute, a name, and that form is a string pointer. And then it has an attribute value. That's interesting that there's the underscores missing there. Oh, this is probably a constant value. Okay, 0, yeah. And then you go next one, 23, subprogram. That's a function. No children. And some unknown attribute value, 2cccd. So this is what's the word? 2ccd is greater than, it's 2 bytes. So I'm guessing that is a user-defined one. So I don't know what the Zig compiler is doing for this. I don't know what that means. I'd have to look into the compiler and see what they're actually doing there. So yeah, you can see that. So then if I do debug info, you can see here's the debug info stuff here, debug information. So let's see, 42, let's see if we find any 44s. Don't see any brev number 44s that we were just looking at, but so that's nice. Object dump is a really nice utility I've been using to make sure that my code has been correct, especially when I've been playing around with my elf parser for parsing the executable file. And then also nice that has the dwarf stuff in it. Just useful for comparing and creating the output I want to test against. So yeah, like here, here's a compilation unit. So every debug file, it's a lot of layers. When you have a debug information, it all starts with a compilation unit. And there's a bunch of information in the compilation unit. You can see like the pointer size is 8 bytes. It's a brev offset is 0, meaning it's just null. There's no abbreviation for this value. Unit type we can see is a compile unit. So there's compile units, and then there's like, what's the other unit? Like linked library kind of stuff. But this one's a compile. You can see the version is 5. That, I believe, is saying that it's not dwarf version 5, even though that's what we're working on. It's a little nuanced. Anyways, sorry, I got distracted here, kind of going over all this stuff here. So back to here. Offset has child. And then we just move the offset by 1. And once we've had that done, we go through. So finally, the child encoding is followed by a series of attribute specifications. Each attribute specification contains 2 parts, which is a lie. The first part is an unsigned leb 128 number representing the attribute's name. The second part is an unsigned LEB128 number representing the attribute's form. The series of attribute specifications ends with an entry containing 0 for the name and 0 for the form. So when we get 20, while the next 2 bytes are not 0, then we'll keep reading. That's essentially what we're doing. I'm sure there's a more clear way to express it, but I could do something like this. So while bytes offset does not equal 0, and bytes offset +1 does not equal 0. Put brackets around this, parentheses. So while those aren't 0, then we're going to keep reading, because I take that shortcut, because rather than parsing the uleb and doing all that calculations, I know that a 0 uleb value is just going to be a 0 byte. That's a special case. And so I can just check if the next 2 bytes aren't 0, then this is, not 0. In fact, I could probably make it more explicit. I should probably write a note there just to let myself know in the future. Okay. Let's see, note. Zero is a special case in ULEB 128. It is just it's not really a special case. It's unique, maybe. It's not really unique either. But 0 is just the 0 byte in ULED 128. As long as the next 2 bytes are not 0, then we are good to keep going. See, okay. And then now there's a lie in here because there's a special there. Yeah, that's right. I was just saying that the attribute form for form indirect is a special case. For attributes with this form, the attribute value itself in the debug info section begins with an unsigned LEB128 number that represents its form. This allows producers to choose forms for particular attributes dynamically without having to add a new entry to the abbreviation table. Which is, gosh, annoying. So this, yeah. Anyways, we'll get to parsing that out in just a second. The attribute DW form implicit const is another special case. For attributes with this form, the attribute specification contains a third part. See, I told you it was a lie. There aren't 2 parts. Each attribute does not contain 2 parts. The liar. There's a third part here. It's so annoying. Which is a signed LEB128 number. The value of this number is used as the value of the attribute, and no value is stored in the debug information section. So basically, they store that. So it's a constant that's, I guess, used everywhere, right? If there's a constant that's used a lot, probably things like 1 and 0 in your compilation, rather than storing a bunch of 1s and 0s in your debug information, you just say, hey, I get why they did it, but it does make the parsing a little annoying. Let's see if we can knock this out. About almost time for me to eat lunch. So first one we're going to do is attribute const attribute equals equals uleb 128. Yes, please. And the type is we're going to do u64 because actually, no, once again, this is another one where we know tag, sorry. Is it no, it's yeah, it's attribute. Attribute. Oh, we need to add the delta here. Delta and bytes. Offset. Yeah, so then we just do the offset plus 7 p.m. Okay, so let's see, so you must be like at GMT because I'm at -7, so it's almost noon for me. Const, no, not const offset, offset. Come on, where is my, oh, there. Plus equals delta. And attributes, yes. Const. Tag, no, not tag. Form delta equals uleb. Uleb 128. U64 for right now. Bytes. Offset. Who doesn't like something I did here? Oh, just a bunch of unused local constants. That's fine. Because we can fix that. Apply the fix all. We will eventually get rid of all these fix alls, but just to make sure things compile when we do it, parameter type declared here. Oh. There we go. Got that. Got that done. The UK. I don't want to make you say where you're from, but I know that there was a Zig Day in Bristol maybe 2-3 weeks ago. I think they're planning a new one if you're interested in meeting up with people who do Zig. Let me see. Zig.day, I believe is what, yeah. Zig.day, Bristol. November, oh, this Saturday, November 29th. There's a Zig Day. You do need to, for this one, you need to, if you're going to go, you have to, you RSVP because the place they're going to be at requires it. So if that interests you. Okay. So we got the form, we got that. So now we got to add that form to. Oh, 3 hours is a long drive. Yeah. I wouldn't. That'd be a long drive. I'm not super familiar. Well, I'm not familiar with the UK at all. I've never been there, but so I don't really understand where Bristol is in relation to everything. Where was I? Oh, yes. So we're gonna now. We need to check if it's one of these special cases. Attribute DW form indirect is a special case. Oh, I wanted to look at that. Real quick. W. So let's look at form as a U8. So it's interesting that the dwarf form is encoded as a. I get it because you have the special cases. But like a dwarf form is a U8. Like it's only a byte right now. And the attribute, let's see. Attribute is U32, and I think that's actually pretty strict. Yeah, because the user defined values can be, well, these are U16s. So even the high user is U16, so it doesn't need to be a 32-bit value. I might go back there and change that because it's only 16 bits. There's something felt like required to be U32. So for right now, we'll put that pin on it and do that. Okay. So we know that the form is a U8, and this is a 32-bit value. Okay. Now, if it's an form indirect, so let's do this. Const form is, let's see. If at enum from int if enum from int, the enter is going to be form. And we need to do like as dw dot form just like switch on it actually. Yeah, if we just switched on this, let's just you switch. Yeah. And then we can say Implicit constant, yes. Do some special handling here. If it's a indirect, also do some special handling here, I think. That's what I was going to look at. For indirect, a special case, the form attributes with this form, the attribute value itself in the debug info section begins with an unsigned. Wait. For attributes with this form, the attribute value itself in the debug info section begins. So this one actually doesn't have any special case. So we can just do else. It's just the implicit constant that is special. There's no field named implicit constant in dw.form. I'm sure there is. But implicit const. You are correct. I am wrong. Okay. So the special handling that we need to do here is this. We need to read another ulib after we do this offset. For this one, this is just a PDF, but I'm using Zathura, so here. Let's see. Why? Oh, there. Zathura PDF viewer. Orc send orc send there. So that's the tool I'm using to read it. Is that what you wanted, or did you want the documentation as well? That is Dwarf version 5 standard. Copy. Yeah, the PDF is here. Copy. Yeah, Zathura is nice because if you use Vim or NeoVim, it supports key bindings very similar to that. So it's really nice for searching for it and searching through things. And just navigating between things like that. So I do realize that it's probably really hard to read the things because it's really small on the screen. Just kind of realized how small that is. So I don't need to follow the link. What I want to do is resize everything. There we go. Resize this to be like that. I actually want a documentation. Yes, there's a 3-minute delay between. Oh yeah, comment when it appears in your board on your screen. Oh, I didn't realize I had the delay so long. But yes. So the documentation's there in the Dwarf 5 standard, and then Zathura is the PDF viewer. So I could zoom in. Why is my zooming? There we go. Zoom in a bit more there. A little easier to see. The attribute form for implicit const is always followed by another signed 128-bit number. And so this is where I had an idea. Oh, an idea here, which is if we run into some implicit consts, we're going to store that data in a, this array list. So what we need to do is do extra. It is really interesting to read. I don't know. I find reading specs can be kind of interesting. Extra equals uleb 128 u64 bytes offset. Eventually, I think it would be cool to get to have like this debugger work on Windows, but Windows uses a different format, and where I don't really understand the Dwarf format that much, I don't want to throw in more complexity at this time. Okay, so this extra plus delta, and we'll do that. Okay. So actually, and then extra delta. It's complaining that that isn't used. Oh, back in 1999, were you working on the Millennium Bug, Y2K? See, extra, so the extra, and what we're gonna do is create some here. So, okay. Do is formats equals standard dot array list. This needs to take some GPA. Hater array. List unmanaged. What was it? Formats. There we go. Formats. Const. Oh, not const. This is definitely a var. Dot init empty. Yes. Got that. We're gonna do the same thing with extra. And then we want to get a brev codes. Okay, get those all empty. And they're not pull allocator into this namespace. Well, let's fix that. Const allocator equals standard.mem.allocator. There we go. Shadows extra variable for outer scope. That's fine. We will fix that here. We'll call this const. We'll just call it in. And now what we need to do is create a while. So here we're doing form. So this is going to be a format. Var format. Format equals undefined. Let's see. format to attribute should equal int, see, enum from int, header, and then format dot form should equal enum from int form okay, and then oh wait, form and index. Yes, I have a bunch. Usually door form, however, in the door form is only 8 bytes, so let me put the index here. So then we got to OR it together. That's fine. Enum, it's not enum from index, it's just a u. Equals. We should probably just do 0, 0, like instead of this, do like 0, 0. In fact, let's just do that. Let's do like null format. Yeah, we just do null and say it's a format 0 and then dot attribute equals enum form equals 0. Six dot no, and then the form is going to equal form equals form dot form equals at enum from int form. There you go. Oh man, lots of enumming from ints around here. Okay, then if that's the case, then we do format.form.extra. Oh, extra, we need to put this in. So now we do extra dot insert, no, append GPA. In. Extra is the extra should be 0. It should be yes. extra length, but we need to truncate it to or at as let's see, truncate. There we go. That's the right way to do it. Found comp time int 16. Okay. So it doesn't like this. I need to do this as an at enum from int 0. And expected door form found comp. Zero. C dot form equals 0 dot extra equals extra should be on 6. Const invalid equals not unvalid, invalid equals standard dot math dot int maxenst. Int u24. Come on. Jeez. What is and dot C. What was it? I should just do you know what I should do is this. Make it valid here. Do it like this. Form and index equals form dot form equals enum from int 0 dot extra equals here x, and this should just be dot invalid. Okay. Door form has no tag with valid 0. Well, we can fix that because it should be invalid tag. It should be invalid. Invalid. valid 2, 3, 4, 5, 6, 7, 0x00. FM int max int max int what are the errors? Unused local variables on the yes found U64. I know. Extra. Okay, I have to fix that, but I'm gonna have to fix that another time. I am gonna go eat some lunch. Thanks for watching today. Let me. Why is it not working the way I want it to? There we go. Yeah, thanks for watching. Have a great rest of your day. See ya.